All right. Another stream. That's perfect. So, yeah, you probably have seen me adjusting my camera. And now we are ready for this spontaneous live stream. This is the third one already. It's started as like weekly streams, and now it's actually becoming daily streams. But yeah, we have a good reason. We have the Pi Pico course, and we want the emulator to be useful for the course. Actually, it's pretty useful already, but there are still a few features we need to nail down. So let's take a look at the chat. So who is here? I see there are already a few people here. Cool. Let me share my screen, and I will tell you the reason for this stream today. So it all boils down to this issue from, where is that? Too many opened up tabs. Yeah. So this issue from we have a few issues like since yesterday, but I think the interesting one is this one from Valerio. And he just tried running the test cases manually against the physical Pi Pico. And I like that. And I decided we could try today to... Hey, Jim, good to see you again. And I decided we got to try to automate that. So basically create some kind of abstraction instead of... just having tests that work against our simulator, have the same code, the same test code work both against the simulator and against the physical Pi, so we can test our tests. And we had this discussion. It turns out that yeah, that Valerio is wearing donkey ears. I also feel like that sometimes. That's funny. Anyway, we had another interesting issue from Paolo that says that row shift amount is 8 bits, not 5. And it turned out we missed some modulo on the on this our shift. So the datasheet says somewhere that yeah, it shifted by I don't even remember where I took it from, but basically we had to modulo 32 the shift amount, and JavaScript does that automatically for us. But I think for the good measures we can just add it, so it will be more consistent with the datasheet. So let's just do that real quick. That was raw from yesterday. Okay, so basically just, you know, take the shift amount and modulo 32 for the good measures. Cool. So it shouldn't change anything. I mean, let's even add a test case for that. So where is the raw test case? If we do the same, but with modulo. So if we add here like 40, that should be, or maybe it doesn't work that way. I think adding 40 means adding 32 twice. Oh yeah, sure. It didn't modify. Yeah, it's the same shift amount. So every every number I put here, like basically every all right. So oh yeah, it's the same. It has to be the same. But yeah, every even number that I will put here will still result in the same shift amount. Yeah. So when R3 greater than 32, great. So we can probably, I'm not even sure how to classify it. Let's say it's a fix, even though it doesn't really fix the bug. Add modulo for the shift in raw That's issue number 14. And again, it doesn't really change anything, like the code was correct anyway, but it just brings the code a bit closer to the datasheet. And we also have this test case. So if at some point we decide to port this code to, I don't know, WebAssembly or something like that, and they have a different behavior, we'll have the test case that will catch that. And also this will probably make sure we don't miss that thing with the module. So yeah, so just a really small change, just wanted to get it out of the way. And while at it, let's also close this issue where we have this test case for this bug. So basically, let's see, the fix was just clearing the bit of PC inside this, I think, exception entry. And I explained the whole like situation in, I think last week or the week, I think it was last week's stream on Tuesday. So what I'm going to do, I'm just going to quickly revert this fix, then remove this, and it's still green, and then change the test case so that it will fail, and finally restore this and see that this passes. So basically we want to check, this is like let's focus on this for a moment, and 2040 exception entry. All right, so this is like the part that tests this code, and this is somewhere here. Yeah, the specific line where we had a fix, and we want to make sure that we clear this low bit of PC. So all we need to do is basically set here this PC with this LSB bit set to 1. And now the test fails, but if we clear this bit, then the test passes. So super simple fix for the test, or addition for the test. Yeah, and now it also, like this small change also tests this bug fix that I did last week. So test B2040. PC LSB bit clearing issue in exception, or maybe exception entry, PC LSB clearing issue C, and then we have this commit number ABA whatever for details. Cool. Oh, wait a second, I want to add the issue number as well, just so that was issue number 11. Yeah, now I can git push it with the correct message this time. All right, and yeah, this issue should be closed, and we are down to 3 remaining issues. Cool. Yeah, I want to set up Eslint, but you know what? Let's do it. Let's do this already. So it takes like 5 minutes, and we are done with it, and we don't have to worry about it. The thing is, I don't remember how to set it up with TypeScript and everything, but we'll figure it out shortly. Yeah, let's install it first. So install Eslint. And then there is like, let's Eslint TypeScript. Yeah, and there is like a bunch of packages you need to install to use Eslint with TypeScript and stuff. So all of those. Oh, and now we have audit issues that we need to fix. So we'll do that as well. Then we need to create this Eslint RC file with this configuration, npm audit fix to fix those vulnerabilities. It's amazing. It says that it has like 3041 vulnerabilities, and then it replaces 1 or 2 packages, you see it updated just 2 packages, and suddenly all those 3070 something vulnerabilities appeared. Like, it's so, I don't know, exaggerated, this number. All right. Yeah, and then let's add this lint as well to package JSON, a script that will run the linter. So lint, and then we can probably npm run lint to lint our code, maybe. Yeah, and we are getting like a lot of annotations or a lot of warnings. That's the downside of adding Eslint while we have like this project already in progress. But I think most of them is like about missing return type annotation. So we can probably remove this warning. So let's do this. Probably here, Eslint disable warning, and there is probably a way to, probably in rules or something like that. So maybe rules, and then this one should be, how do we disable it? Maybe just set it to false, and it's missing a comma. Let's try that again. Something went wrong. So, 0 is off, just 0. Okay, so we should have less problems. Last time we had like 168, and just by disabling this this rule, we are down to 52, and now we can start fixing them. So first of all, let's enable the Visual Studio Code integration for Eslint. So we'll get to see the errors here, and you can see we have a bunch of errors about unused variables, stuff that we defined but we still haven't used. But we can probably disable this at least for this. Maybe not for the entire file, but for this section with all those constants, because we may need them. Enable it again. We may need them in the future. And then we had those things that says we don't really need the type annotation because it can be inferred. But I say I don't really care about this, so let's disable it for the entire file. What else? We have an unused variable. That's true, we don't need it. Go away. What else? Use const, and there is a way to Eslint fix all auto-fixable problem. I think this is an auto-fixable problem. Yeah, you see it fixed it to a const. And now what do we have here? Interesting. I think we just found another bug thanks to Eslint. I mean, I don't think it should fall through to the other test cases, right? It doesn't make sense to me. So, thankfully, I don't know. Maybe this is one of the bugs we were like hunting, or I don't know. But yeah, enabling Eslint and spending like this 10 minutes already paid off. And thanks. So Jim is asking if I'm using Visual Studio Code on a local dev environment for this project. Yeah, it's Visual Studio Code with a great plugin. I mentioned it in the past called Wallaby for that shows me all those tests status as I type. And now, thanks to Eslint, we found another bug, or so I think. Yeah, I wonder. This means that before the fix, these 2 lines have executed. Yeah, and it's too bad the tests haven't coded. Anyways, let's return this. So yeah, one less bug to worry about. What does this mean? Oh, it doesn't like the fact that I'm declaring a variable inside a switch block. So let's wrap it in parentheses just to make it happy. And what else? So this one doesn't get arguments, but yeah. So maybe we should keep this. Otherwise, this creates another error, and just tell Eslint it's okay that we have an unused variable here for now. Oh, we have it to do here. All right. Cool. So we fixed that, and now inside clock we have those. I don't like this rule. It's annoying me. This inferable types rule. So let's remove it as well. I mean, we can always decide we want it later. So this one goes away. Let's see what the situation for the entire project is. Yeah, we have only 12 more errors. So yeah, this is like no unused var. So I don't care about no unused vars for this section. So let's disable it. I mean, we'll use those. We need those alarms for the next lesson for the next class in the course. So we'll need to use those this week, either maybe today if we are really lucky with the other things, or on Tuesday. What else? Okay, PC is assigned but never used inside the assembler spec. Okay, so perhaps we don't need it then. Yeah, we will probably need this in the future, so we know it's okay. Ooh, interesting. Expected a break. Where is that? What is going on here? Is this another bug? Read register, no break, fall through to write register. Wow, this could ruin GDB debugging session. So yeah, so those missing breaks are really like, they are really a problem. I'm happy we got this. We spent this time running Eslint, and only just to find those unexpected any. No, we don't want Eslint to check the dist folder. So there is like Eslint ignore as well. Ignore, you don't need to check dist and node modules, just ignore them. And two more problems to go. So what's here? It doesn't want an entity constructor. Maybe it's right. It doesn't like this any. Why do we have an any anyway? Don't think we should have. Like, it's probably a bug to have this any here. So it's good at it. And here, yeah, I don't like this require. This is like a solution to being able to run this code either in the browser or in Node.js, where this performance is inside the yeah, I don't like it either. Maybe there is like this trick, but then okay, it's happy. So that's a trick that will also so if we have this in our code, Webpack will sometimes be picky about the require, and it can fail using this code in Webpack. So this fixes both issues, or so I hope. Okay, so now we have happy linting, and I'm going to do one more thing, which is automatically running the linter whenever we commit. I don't remember, there is like a tool called Lint Stages that does this for us instead of pretty quick. But let's see how to use that. I have this in AVR.js, so it's going to be a copy paste. And hi Valeria and Punith, good to see you here as well. So let's see, package JSON. I just can't describe how happy I am that we decided to do this thing with Eslint just to enable it now. Okay, so this is like the configuration for Lint Stages, for Lint Staged, for all like the TypeScript file, run eslint --fix, also run prettier, and then add them again. And then we can set up Husky. So Husky is just a tool that runs another tool whenever you are about to commit. So it will run Lint Staged, and Lint Stage will go over all the stage files and then run those tools. So Eslint to catch any errors, and something that can be automatically fixed, like changing let to const will be fixed for you. Otherwise, it will just throw an error, and prettier will format the code. And then we can remove the older tool that did this for us pretty quick. npm install to just update the packages, and I think we are good to go. We can stage everything and except this to-do file, we don't need it. Yeah, and yeah, I think we are good to go. We have this Eslint ignore, this Eslint configuration, and then yeah, so yeah, nice. Sure, let's just, you know, run the code once, and what do we even do nowadays in emulator? Run hello UART. Okay, that sounds fine. Npm start, and see that it still prints hello UART. Okay, good. So it still runs. Chore set up Eslint, and that's issue number I think says 6, 7, number 10. This also fixes 2 bugs in we had this one with the another stupid bug with the missing break. Where is that? Yeah, that was in exception return. Missing breaks in switch statement in exception return. Missing breaks in switch statement in that was inside a GDB server process GDB message. GDB message. Hooray! No more this annoying missing break bug. Like this one is actually I don't think this one is too bad, because what happens if, yeah, because usually it should have just like for most values of p, this should have just returned something. So if we would read from a valid register, which GDB would obviously do, then this would return and never fall through to the right register. But you know, it's still a good idea to have this break here. But this one is actually a bug. Like this one is we have seen that without this, the test code also executed this line, it covered this line that it shouldn't have. And when we added this break, now this that was in RB2040 exception exit return. Yeah, now we can see this one is no longer green, so it did change the flow of the code. Right, so oh, forgot to commit this one. And page meant edit. I want to check out the log message again. Yes, good. All right, I like this quick bug squashing or issue fixing session. So we fixed most of them. Now we have this cool, I think that's actually the reason for the stream today, this issue from Turo. Before we get into that, let me just show you something I've worked on today. So last time we started adding cycle counting. So we are counting the number of cycles each instruction takes. So we have sort of started working towards having a cycle accurate implementation. So the first thing I did, we had this cryptic thing in the datasheet where it said, not here, yeah. It says that for some of the instructions, so that's something we did yesterday, adding those cycle counts, and for most of the LDR and STR instructions, we have 2 if to HAB interface or STS, 1 if to single IO port. So the time of the write or the read depends on where we are reading or writing from. And yeah, we have this method, slow IO, that sort of that does that. So in every read or write, we are just updating the number of writes if it's slow IO. But I was curious, what is this STS? Because if you look for this word, it doesn't really appear here. And I was also curious about, like, if you check this bus fabric, you see there are like, where is that? Yeah, you see there are like all those peripherals on the HAB light crossbar, like the SRAM and ROM and Flash, and they should probably get faster writes than those peripherals on the APB splitter, which are like one hop further than those peripherals from the CPU. So I opened an issue. Where is that issue? Yeah, I opened an issue for the Raspberry Pi organization, Pico Feedback, and they were pretty quick to explain this. Eventually, I will share the link in the chat if you want to dig in. Eventually, I concluded that there is, like, for most cases, it's 2 cycles per read or write. But for these APB peripherals, for those ones, all those UART, whatever, it's actually, where did it go? Yeah, it's 3 for reading, 4 for writing, and you can find like all the discussion here. But then that Graham, that nice person that always comments on the streams and adds useful information, said that XAP, like the Flash, is 2 cycles at best, but it makes it longer if it misses the XAP cache. All right, so it seems like it's a bit more complicated. I tried reading about it, and I can't really figure out how long it takes to read if we are missing the XAP cache, but I have a feeling it's about 20 or 40 something around that number of clock cycles. So it's probably pretty slow to read from the Flash if it's not cached. And while looking at it, I also noticed, like, reading all these scouting for this information in the datasheet about how this whole thing works, I also noticed a few things that we still haven't implemented, and I don't know if I will be able to find them right now. Probably here, or maybe not. Oh yeah, this XAP cache. So we haven't implemented them. I don't think they are important because I don't think we ran into any issues with them yet, but it's just something to keep in the back of our minds. If we know that the Flash is mapped into 10 million hexa, but then there is also 11, 12, 13, and 15 million hexa, which those 3 also access the XAP, the same like Flash, but there is like accessing through this address space won't update the cache. It just reads from the cache. It doesn't update the cache, and this one doesn't read from the cache. It updates the cache, and this one just bypasses cache completely. And in terms of the simulation, it would be super simple to implement that. Just ignore this value, this digit when accessing Flash, And then you can also like read from the cache and write from it directly. But I think for most part, yeah, this is like useless unless the cache is disabled, and who wants to disable the cache? So I think this is useless for most use cases, but it's just something to keep in mind. And we have also something similar for the SRAM. So you have like those, we have like this SRAM at this address, and we implemented that. But I noticed that there is like another copy of the SRAM here. And this is something we should probably worry about at some point. I hope that right now we are not hit by that, but yeah, maybe I will just open an issue now so we won't forget about it. So yeah, just fix 3. Let's open a new one. Let's create implement additional SRAM XAP addresses for XAP flash. We have, where was that? Actually, let's start with yeah, let's for SRAM, just quote this. So we know what to look for when we come to fix that. So we had this here. Yeah, no, I think it was here somewhere. Yeah. All right. Just don't know if it's used by anybody, but we need to let's just we need to remember we need to do it one day. Otherwise, at some point this will pop up. Anyway, so okay, so so I was talking about the cycle accurate thing. So I tried to implement it into Wokwi, and let me show you what it looks like. So this is the standard Raspberry Pi Pico simulation that we have right now. And if you run it, we sort of made a simulation so that it adapts to the real system time. So you can see it runs at around 100%, and basically this browser is really slow, but it slows down the browser. But you can see, like, if we sleep 250 microseconds or milliseconds, actually, that's real time. We sleep 250 real time milliseconds, but this is the same simulation, but this is a different range, which is cycle accurate. So it means it runs at, I think, 120 megahertz or 25, and this means it counts 1 second every 120 or 125 million instructions. So you can see it runs much slower, about 12% of real speed. But then the amount of instructions that is executed before each digit updates here is much more accurate. I mean, we still haven't done all these like cached, non-cached XAP access, and our cycle counting is still not perfect, but for the most part, it gives you a good estimate of how many instructions would run per digit on the real hardware. So it models, I think for some use cases it will probably model the real hardware better. Anyway, enough with showing what I did, and let's do. So to the main issue of today's stream. And oh wait, one more question from Jim. So what's the megahertz for the CPU simulation? So it's a good question. I guess I just answered it right now. So it depends. If we are sort of trying to force it to run in real time, then I guess it sort of simulates 12 or 14 megahertz, depending on your CPU speed. It just sort of cheats, it lies. It just advances the clock faster than it would in real time in order to make it seem like it's running real time. And on the other hand, if it's cycle accurate, then it's the same as the real chip, but then the simulation runs slower than real time. So it's a trade-off. All right, let's do this. Many tests report the wrong expect value. So Valero said he found 3 tests that fail. So let's start digging into this and creating this abstraction. First of all, I hope I finished my LAN and fixed my LAN, my Wi-Fi, and now I think if we are, where are we? Single instruction. Oh, it was not held. Yeah. Now you see GDB is fast. It used last time it was super slow when it communicated with the Pi because I don't know, I had some problem with my Wi-Fi, and now it's fixed, and hopefully it will be fast enough now when we run the tests against it. So Steve is asking, to have the choice of fast or accurate going forward, or just show the speed difference. That's a good question. I think ideally there is a golden path where you can it really depends on the code that you are simulating. We still don't really implement wait for event or wait for interrupt, but once we do, if the code is just sleeping and waiting for interrupts most of the time, then we can do cycle accurate simulation, and that would be just fine, because most of the time we will not run the code, we'll just wait for the next timer tick or user event, and it would run just fine. But then if the code is busy waiting, then we definitely don't want to simulate so slow. So in that case, we'll probably switch, like a better choice for most projects, a better default would be to use just the real-time simulation and not cycle accurate simulation. And then I think some kind of mechanism that would switch between those, or like that would be a good default, switching between cycle accurate when there is a reason to, and back to maybe when we have the PIO, for example. At least for the PIO block, we would need cycle accurate, because if you want it to work with neopixels, then the timing has to be very accurate. So yeah, that's a good question, and it's an open question. We'll have to figure it out. Eventually, we may be able to squeeze even more performance out of the simulator once we start optimizing it. And I think we can get it much faster if we write some part of it in WebAssembly, or do some kind of pre-processing to the program, to the simulated program, to translate it either to JavaScript or WebAssembly. But that's a lot of work to do. So first, let's get everything working, and then we can start thinking about those kind of optimizations. And we still have a lot of work to get everything working. All right. So the plan is for this automatic testing is just to create, I don't know if we'll call it CPU debugger, some kind of wrapper for these CPUs. So instead of using the RP2040 class directly, we'll use the wrapper, and that wrapper will know we will be able to configure it to connect to GDB, and then we'll be able to test it against the physical device. So before running to create this wrapper, let's also create a small utility, Gdp Client. We have GDB server already, so now we have the GDP client, and the GDP client will just connect to GDB, and will sort of expose a convenient API to work with GDB. Pretty much the opposite of GDB server. Probably we can move all these GDB stuff to, I think it will be all those functions will be useful both in the client of server, so we can probably put it in a GDB file that will be sort of common, and then just export them. Export and export, cool. And then just import whatever from utils GDB, then GDB response, and this one, and this one, and this one, and this one. All right, one is probably still missing, this one. All right, imported, and great. So now the GDB client, we need a constructor, and that would have probably string. We are not writing C, we are writing TypeScript. Address string and port number. Let's say it's by default it's 333. All right, and now we need to, and I don't remember how to do this, open a TCP socket. I don't think I've done this too many times. Usually I just work with HTTP requests. We need net.server, no, net.socket sounds good. Net.socket connect, yeah. Okay, let's import net from, or import from net. What can we import? Do we have like, no, we don't have promise interface, probably socket, and then private socket, and let's see, socket, this.socket, just actually, we can probably create it here in the constructor. Do we need any special options? Readable. That was ignored. No, not important. So this.socket.connect, or maybe we can just, you know, make it simple and add a connect method to the GDB client. So async connect, and then say this.socket.connect, and how does that work? Connect. Port host and connect listener. Okay, port. Let's call this host instead of address. Host. And the completion listener. What is the connection listener? To the connect event once. Okay, so yeah, let's return a new promise. Let's make this API promise friendly, so we can use it with async and await. So new promise, and resolve is once everything goes good, and then this.socket. If it has an error, then just call reject with the error. Otherwise, if it's connected, we call resolve to say we finished connecting. Yeah, and I think that should be should do the trick. Now when we are connected, we can start exchanging data. Let's just create a quick, not sure if a test file would be very useful here. Maybe just a quick script to, maybe we can just run this for now. Const client is new GDP client, connect to Raspberry Pi, add port, we don't need this in the constructor. So client.connect to this, await, and this is async, and console log connected, and then we just run main.catch console error to print if we had any error in this async function. All right, so now ts node src utils GDB client npx this, and let's also take a look at the OpenOCD. Oh yeah, it rejects the Gdp connection because we are already connected. So let's quit here. Now let's try that again. And yeah, accepted connection. Cool. I wonder why it rejects the connection immediately, even though it has no reason. Maybe because we just close the process right after connecting. So let's send a message after connecting. Let's add a method that would query registers. Query registers, or maybe read registers. So in this case, we just this.socket.think write, and then we write GDB response, or maybe we should rename this to GDB message. I think it encodes the same the messages with the same checksum in any case. So let's see. So we have this message to read registers G, and then let's do this. This.socket. Actually, inside the promise on data console.log socket received data. Okay, so now we should probably be able to read the registers as well. This client.read registers, or maybe not if we missed anything. Oh, nice. Yeah, we need to convert it to a string, but this seems pretty it's a Node.js buffer, so let's try to convert it to string and see if we get, yeah, this looks like a legit response from GDB. So we can see that once we are connected, it sends us a plus, probably just to act the connection, and then whenever we send a message, it sends us a plus, then GDB reply. So first of all, let's just rename this function from GDB response to GDB message, because it's used both for requests and responses. GDB message, yep. Cool. And now, once we have this, we can probably Gdp Client. Yeah, we can probably implement the part that actually waits for this response. So there are a few ways to go about it. I would say whenever we get new data, we just like sort of decode it, and then if there is anybody waiting for it, which there should be because somebody have requested this data, then I mean, inside those async, we can do this read response. So we can do it in several ways. Yeah, I mean, we can probably add this. We only expect to get a plus, so we can wait for this plus. We can actually, instead of resolving when we connect, we can probably resolve if data to string is plus, then resolve. This means we successfully connected. Otherwise, it's a promise of void, so resolve doesn't get any parameter. Otherwise, we reject with new error, invalid data from GDB server, and then we just data, print this data. So now when we connect, we should have already seen this plus, this first plus, and now when we have this, we can implement this private read response, and this one should just again add this.socket.once data, or maybe we should just, you know, on data, just attach an event listener that will read data until we found a response. if this.data or const, maybe we'll call it buffer, data is buffer to string, if and then return new promise, but this time it's a promise of a string. And then we have resolve and reject. So, and whenever we get new data, we check this. We need some sort of a state machine here. Or you know what? Yeah, it can arrive in multiple packets. So we need to have this hash sign and two more. It's actually pretty much the same as decoding in GDP server, I guess. We just read until we get this hash sign, and then the response should, first of all, we should see if we get any ACK. So if we get a plus, yeah, let get ACK is false, and if not get ACK and data is not a plus, then then just reject. And also, how do we cancel this listener? Let's do this like this: const listener buffer is just a buffer. Okay, and now whenever we get data, we just call this listener, and whenever we quick, so I think it's off to just remove this listener. Okay, so why is it intervening? Oh yeah. Okay, cool, or not so cool. It's still not happy because we are missing parentheses. All right. So got ACK. If the data is not this, then just reject new error, didn't get or no ACK from GDP server. Otherwise, I don't remember. I think when we have an error, we just return an empty response. So just an empty GDB message. So let's see, what's the fallback? Yeah, an empty response means an error. So basically we should just keep reading until we find hash and then two more characters. So instead of data, let's do let data is an empty string, and then we just add this to data, whatever we receive. And wait a second. Okay, if not got ACK, then if data 0 is a plus, then we got an ACK. Got ACK is true. Otherwise, we just bail out. All right, and then we also want to just remove this. So just remove the first character from data. All right, so this handles the ACK, and now we need to do this. If const hash index is data.index of hash. First of all, we need to make sure that the response starts with a $. So if data0 isn't a $sign, then we just bail off. Invalid response from GDB server, and let's also include a response just for the ease of debugging. So yeah, so that's if we don't get this $sign, and then if we got it, then we are looking for the hash index, and if hash index is if it finds it in the string. And also we have like hash index. We have the 2 extra checksum characters after this hash. As we can see here, there is like plus $ response hash and 2 checksum. So if we got enough data, then we just resolve and we return we remove the listener and then resolve with the data between the hash index or data at substring from 1, removing the $ at the beginning, and to hash index -1, which is, we have to make sure it's less than the length of the string. Yep. Right, we just return. We don't really need to check the hash. We can probably, the checksum, we can probably assume it's correct. If anybody really feels like checking the hash, the checksum, then feel free to send the pull request and check it. Yeah, I think this should probably do the trick. Let's just console log read registers should return this. So it should return just, oh yeah, an error, invalid response from GDB server. Where did that happen? Here. Maybe, why is it empty? Interesting. Yeah, let's just make sure that console log data. Oh, maybe. No, but oh yeah, I know. Maybe it's sending the plus and then this one is a different packet. So if data.length and otherwise we just wait for the next packet. Right, so this is a bit better. It still haven't failed, but we don't get any response from read registers. I wonder why is that? Let's console log data. What data did we get so far? Yeah, this seems correct. So maybe hash index is off. Let's print whatever we resolve with, and that should be this. Yeah, it seems to resolve with the right thing. So how comes read response? I guess I know what happens. We need to return the result from read response. That's why we don't get a result here. Okay, cool. Read registers returns the right thing. And now, right, so we have this this basic of the implementation of the Gdp client. We still need to implement a bunch of functions, but we got the basics working. All right, let's remove these console logs, all console logs in the middle. All right, so yeah, we have read register. So now we just need to parse this into an int array, but I think we already got that logic. So const response, and then I think we did the same in GDB server when we have this write register, so we don't have, but they probably, there is like decode hex buff, yeah. So we can just return decode hex buff with a response, and that returns. You don't have it, you do have this method. That's why we moved it to this GDB file, and then let's just new insert it to array, just to convert it to array of interesting, what's the length of this buffer then if it's not a multiple of 4? Maybe we are missing 1 byte somehow. Yeah, I think I know what's the problem. This end is not including, so we removed 1 character too much, and that's the problem. Yeah, now we can see we read the registers, and that's from the actual Pi. And this is this console log. Cool. Let's add another like dump registers. That will be just useful for debugging. So const registers equals this.read registers, and then for I to 16 I++, and then console log register names at I equals, and const register names are just like 0 or 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10 or 11, and then R12, and then we have, I think, SP and LR and PC, right? Let's double check that. PC and SP, and probably LR is, yeah, 14. Yeah, all right. And I think the other one, the last one is XPSR. So, oh yeah, it's actually, we can do it for I register names.lengths, and these dot registers, or not it, just registers to string, or maybe we have a better method for that, like encode hex uint32, probably nicer. 0x plus code uint32 registers at I. All right, and let's import this. I hope one day they will fix those auto imports. Oh yeah, we need an await here because this is async. Now let's call client.dump registers and see if it works correctly. Yeah, I think it's almost correctly, because this seems to be like the value, a good value for PC. Yeah, and not a value for XPSR. Yeah, and yeah, let's see if we missed something. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. Well, let's just compare it with what we do in the GDB server. So we have like so we have 17 registers, and here how many do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7. Yeah, it seems good. Let's just compare this with what GDB says if we just connect and then info registers. So, ooh, it's totally different. Interesting. Yeah, let's disconnect and run this again to see if GDB has changed anything. Yeah, it seems like something is off. I mean, it's not totally off, because I think this is like an issue with the Indianness, probably, because yeah, it's reading the correct value, but the byte order is incorrect. So we need to fix the byte order. So maybe that's the problem. How do we encode those in GDB server? uint32 array. So it seems like we don't change the byte order. Maybe it's encode XUint32 changes the byte order for us. Yeah, it does. It codes them as Little Indian. So if we did something like this, it would probably be fine. Let's see. Yeah, now it makes a lot more sense, like these values, and they are on par with what we get with GDB. So yeah, we have a code that read registers. Let's just add another method, function dump uint32 value number, and then it will just pad it. We don't have that yet, I guess. So const value or let str is value to string 16, and while value.length is less than 8, just pad it with 0 value str. Okay, and then return value str. Cool. And now we can use that method instead, just to print them nicely. Just dump uint32. Right. Cool. So at that point we have this. Why do we have undefined though? Oh yeah, it's just dumping them. It doesn't return the value now. Okay, so now we have basic proof of concept that we can connect to the GDB server on the Pi and read registers, and then we can start implementing some more methods and integrate it with the tests and see if that works, and then write the abstraction and adapt the test to use that. Right, first of all, I want to remove that there is an annoying console log somewhere. Yeah, this one, socket received. I don't care what it received now. Cool. Yes, we can dump the registers, and now after dumping the registers, let's add a read register index number, and then this just return this dot socket dot. Yeah, I think it's going to be a repeating pattern, so let's private async send command string, and then it just does this. Just encodes this command as GDB message, writes it to the sockets, and reads the response. So then we can do something like response is just await this dot send command g, and then inside this read register we are just sending, I think for reading a single register it's p, yeah, p followed by the register index, so p and then the register index in decimal, hexadecimal, so p and then index, and then we have a method to encode it as byte, I think encode x byte, yeah, just to make sure it always comes with a leading 0. Yeah, import. All right. And then we can just decode this. There is like I think decode hex buff. Isn't there like, yeah, decode for XUint32? I think that would be also useful. Decode XUint32, and it just like decode hex buff coded string of this encoded thing, and it converts it to a uint32 array and returns the first element, and return this code xuint. Yeah, maybe we can also do the code xuint32 array. and then this one will just use this and return the first element encoded, and this one return the whole array. And then we can also use this in the other method, the registers, like here, just return decode uint32 array from response. Cool. And I guess we can keep it as 2 lines, that's fine. Decode uint32 and response. Now we can, that should be async. We can test it like await console.log, and we have like those extra registers like MSP, which I think is number 17. Let's check in Gdb server. MSP, yeah, 11exa is 17. So that's MSP. Wait client dot read register this one, and then we want to just dump uint32 and see if it's the same value that we get from from GDB. That should be this. Yeah, seems very much the same value. So now we can also read registers. Any registers. Let's just, out of curiosity, see what happens if we read like R1, if it's like the same value as we get from dump registers. Yeah, no? Yeah, it's the same value. Cool. Right. All right, let's implement write register. We need it for the test. So write register and index and value, and then we rest uppercase P and encode hex uint32 value. And we basically don't need to check the response, I guess, because it should be just empty for write register, right? Write register. Oh, it should say okay. So let's just make sure that if response is not okay, prone new error, invalid write register response. Okay. Now we can try to write register first. Let's say we want R1 to have the value of food dude, and then dump to the registers, and let's see if that works. Connected, and then it goes away. Probably some problem here, but why didn't we get any error indication? Interesting. Let's console log the response here. Response. Does this say anything? Set register packet. Okay, so yeah, it probably disconnects us, so maybe we should also add an error handler here. So yeah, so once we are connected, yeah, we probably reject this promise when we have an error. So yeah, we should probably change this code so it will be more resilient. So once we are connected, we should also remove this error handler here, an error, and whenever we get an error, we just print it to console. Gdb socket error with the error. It's a bad idea to swallow those errors. So yeah, that didn't really help. Yeah, I wonder. Anyway, we'll fix it later. I just want first to get it to work, so probably should be equal instead of comma. How do we do it in the Gdp server? Yeah, we split by a comma, so there must be a comma there. And I think it worked, right? MSP equals, did we write to MSP? I think we write to, yeah, R1. Oh yeah, that's R1. We say MSP, but we print R1. So yeah, we can also write registers. I think the next thing we need is a single step, right? Most of the tests just step execute an instruction, and I think for step we have this vcont, if I'm not mistaken. Vcont, yeah, vcont semicolon s. So let's try to do that. Const response equals await this.send command. Vcont s const log response. Don't remember what response it sends. I think it should send the exception code or something like that, the stop code. But let's try that. Await client.step, and then maybe we'll call it single step. And then let's also print the value of PC after that. So PC is, I think, 15, the 15th register. And we expect it to increment by probably 2 after executing a step. Yeah, I think we don't need to decode the result here, or do we? Where does it fail? Here in read register. So yeah, let's print the response, I guess. We got a response we didn't expect to. 0 0. Yeah, I guess this has to do with this got empty response for single step. Single step, what happens here? By the way, let's see if PC has incremented 4e. No, it seems like PC didn't really increment, so it doesn't seem like, yeah, it doesn't complain here, but it doesn't seem to step either. Let's see what happens with the real GDP. Set debug remote 1, single step. Oh, is the program not being run? Whatever. Oh yeah, I'm already connected here, so probably it doesn't let GDB connect. Okay, set debug remote 1, single instruction. Ooh, so many packets, but yeah, I guess all of those are reads. So this is what it sent: vcont s, and then it gets t05 thread 1, probably the thread status. So 1c. And we can try to send this whole thing and see if it changes anything. And we expect the response to be this. Let's try that. Oh yeah, we got the response that we expected, so probably that was the problem. But we still get strange thing from the next command, which shouldn't. First of all, if response starts with, if it doesn't start with T, then throw new error, invalid single step response and response, otherwise we guess it's fine. And then we need to figure out what happens with this read register. Why does it fail? Let's try to read to just dump all registers again and see how that works. Right, running it again. Yeah, now it seems to be happier. Wonder. Oh wait, I think I know what the problem was. Yeah, 15 hexa. I don't think it's probably an invalid register. We need 15, not 15 hexa. Oh yeah, thanks Tony for spotting that in the chat as well. So yeah, so now you can see that the PC was indeed incremented by 2, so it's indeed single stepping. That's nice. All right, so yeah, I think we have most of what we need. The other thing that we need is the ability to write to the memory. So async write memory and then read it back, so we can use it in LDR and STR in the test for LDR and STR. So address number and data is just a byte array buffer. And then for writing, we just send this command of what is write memory. I think it's M or something like that. M, and then it's separated by address, length, and data. So let's just see what GDB sends. If it does set, say, we need to first of all enable debugging, remote 1, set to X. What's X? I haven't seen any X so far. Binary downloading supported by the target. Interesting. Yeah. Right. What is that? It seems like it's octal encoded. All right, interesting. But I just want to write to the memory. I don't want binary downloading, whatever that might be. But it seems to like those X packets. So let's quickly read about them. We have this GDB. What is actually we have the format for M. But let's quickly see what is this X. Write data to memory where the data is transmitted in binary. X is binary data, but I think we can use M. Why not use M if we have it? Address, length, and hexadecimal data. Yeah, all right, so that's the command is, we said it's M, and then we need to encode the address, the length, and so there, comma length. Do we need a colon? We don't. M space address, length, and then data. And then instead of just length, it's data.length, and we want to encode it at uint32. Encode xuint32 for the length. Just call it length. Length is this. Const other is encode xuint32 of address, and in data is just encode hex buff data, I guess. Do we have encode? I think it should be uint8 array. That would make our life easier. And let's console. So it should say OK just as write register. So let's and then we have this. We do have encode xbuff. We just need to import it. Cool. we'll need the code in a second for reading. So write memory. Right, I think it should write memory. Let's see. Let's try to write memory. Await client.write memory, and let's write this address and write this. I don't know, 1, 2, 3, 4, 5, 6, 6, 6, 6. New uint 32 array with just this value, and then new uint 8 array. Yeah, all right. So at this point, we should also be able to write to the memory, and yeah, it's not happy about something. Oh, Gdp is already connected, so obviously it won't be happy. Just refuses to our connection. And now let's run Gdb and dump the memory at this address. Let's see what's there. Not connecting to the Pi. Unable to decode memory packet. That doesn't sound very good. Can't resolve name. Maybe just Raspberry Pi without a local. It worked a moment ago. Trying again. What's the IP address of that? That's the quick way to find it. That's the IP address. Okay. Now you know the IP address of my Raspberry Pi. Oh, open OCD, restart OpenD. Really kill all OpenOCD. Restart OpenOCD. Now it will probably work without. No, it needs the IP address. Not sure why it stopped working without the IP address, but anyway, let's see what's at this address. No, we haven't managed to write to the memory, and there was some error message. Let's print this command that we sent to see if we did send it correctly or not. I don't see anything that looks like this command here. Did they save the file? Because this says unable to decode memory packets, so there is probably an issue. And there is also failed to write memory. Okay. Yeah, I think we have an issue here. We are swapping the address and the lengths, and or yeah, I think we are like encoding them as Little Indian, which we shouldn't do. Why do we do that? Why is it like first? Shouldn't be. Yeah, E0E, which means error. All right, let's. Yeah, this is like Little Indian encoding, so maybe we should have another method for encoding Big Indian. Sorry about the non-creative name. Okay, encode x32 uint32 Big Indian. And then we can just do something like that. Just manually do the encoding. So first of all, then, and finally, and all of those are going to just take a single byte. Actually, we can also do this here, just to make sure we only get 1 byte, and then we can this method instead, and hopefully have this work correctly now. Okay, this seems better. and I don't see we got any error. So now let's connect with, and it didn't complain about anything. Now let's connect with GDB, XX this address. Yeah, it's written successfully. Let's add another, and I think that would be the final one, method to read from the memory. Gdp Client, write memory. Async read memory, and it gets address, number, length, number, and encodes them similarly. We don't need so many copies of that code. No, we didn't want to move it. Yeah, that's fine. Now we have lowercase m and just the address and length. And this is just str links. Maybe we'll just call this address str as well, and use the same convention here. Okay, and we don't need to print this command because we know it's fine. Now return decode hex buff. Just decode response. Cool, and now we can try to console.log read mem await client.read memory at 20 million, and we want to read 1 byte, and we should just get, or let's just read the whole thing. Now it bails out. Oh, because GDB is connected. Yeah, interesting. Oh, we read 4 bytes, and now let's see what does it look like as a 32 array with the buffer of this. Let's decode it. Oh. Yeah, we should wrap this in parentheses to get a result, and let's just dump this hex file, dump uint32. It's getting pretty messy, but it's just temporary test code to see that we can read memory, and yeah, it seems good. Let's change it to 50505052. Just one more quick test to see that we get the same result. Yeah, so now we can read registers, read memory, write memory, and single step. And I think that should be enough for now for the, and yeah, terminate batch job. One final thing I want to fix is like getting proper error messages, because I don't like the fact that it just quits whenever there is an error. Console.log, there was an error, just to see if I'm missing something here. I think not. Yeah, it probably somehow swallows this error somewhere. This is the first suspect. Console.log socket error. Yeah, socket error. No. So why does it just, I mean, we expect connect promise. Maybe there is like another issue, another like thing. Maybe this, it's not an error, but it's a different event. Maybe it's, let's go back to the docs. Thanks, Tom, for the feedback on the chat. I love noted that you find the simulator so awesome. Yeah, as you can see, it's a lot of work, but getting comments like this one makes it pay off for the hard work. Yeah, and Tinkercad, I think it's a great product. I just wish they, you know, it seems like they stopped working on it, which is kind of sad. if they kept working on it, it could have been like great as well. All right, so socket closed. So maybe that's the problem. Yeah, we have socket closed, but whenever the socket is closed, let's at least print an error. Socket closed, so we know what happens. I think that's good enough for the tests. So on error, or maybe yeah, let's do it like that. So here, if we have an error, we reject, and we only need to do this once, and same here. And now let's also add this into this read response. So let's add so whenever we are waiting for a response, if the socket closes, yeah, let's do it differently. Let's hold like the value of the private reject current response. So whenever we have an error and there is like an outstanding read response, we are going to just reject it. So this dot reject current response equals reject. Yeah. And if we have this, it's just null at the beginning, so it can be either, or we can say it can be optional, it's maybe undefined. And whenever we have an error, we try to reject, yeah, we can reject current response, just reject the current thing that is waiting, and then we can say here this dot reject current response equal reject. So if it happens during connect, it will just connect the reject the connection, otherwise it will reject whatever. And then we can say new error, it rejects with an error, and then it will say new error, socket error, and the error. Or we can say here just socket closed. Okay, now we should probably get somewhat better error reporting. Let's see if that worked. There was an error. Okay, that's better. Now we can catch it with just console.error as we had before. Okay, cool. Socket closed. Maybe socket was closed. Sounds better. Was closed. Do we have like any information here? And now the reason it's closed is because we already have an open GDB session. Just false. That's not useful. Okay, cool. Yeah. So we have open GDB session, but now we know that we have an error and it just doesn't silently die, which is so much better. Okay, let's just run it again to see that the happy path also works. Yeah, seems to work. Cool. So we have a Gdp client. We can remove this whole main thing for now. We don't need it anymore. It was just for testing that this Gdp client work, but now we know it works. Yeah, and then we can probably feed Gdp client, implement Gdp client, Gdp server client actually. All right, let's see if we have any console logs that shouldn't be here, like this one. And dump makes sense to have it here. All right, so we have this client, and here we have these functions that are now these shared functions that have moved, and we also renamed GDB response to GDB message. But other than that, we are good. First step done. We have the Gdp client, and now with the Gdp client we can finally rewrite the tests. So let's take a look at the tests, and I think that's not a test. I think that's also a great opportunity to refactor some of the tests. There are like so many tests in a single file, and I think we can just move most of them to instruction set .spec.ts. Just have a file that deals with the instruction set instead of having everything in a one enormous file. So let's start with that. It's like, yeah, this one. This whole thing is testing the instruction set, and then cool. Describe. It's no longer Cortex M0 plus instruction set. Cool. And then we should just copy all those imports and stuff from the beginning. All right. And is there anything unused here? I think not. And we can remove all the unused stuff from here. Ooh, a lot of unused stuff. All right. Maybe just instructions.spec. Instructions. Yeah. And yeah. Why isn't it green though? Let's restart the test runner just to make sure it's not some kind of caching issue, even though I have a feeling it's not a caching issue. Right. Oh yeah, it was. So now everything is green. All tests are passing, and let's commit that test that like the yeah, test move instruction set tests to separate file. Right, so we did that sort of refactoring, just preparing for rewriting the tests. And now we can start creating this kind of abstraction. So for starters, we'll just start with one instruction like this one. And instead of having this RP2040, we can probably create a method function, create, how would we call it? Naming things is a really hard problem. So create test driver, or maybe, don't know. Yeah, go ahead and suggest a good name for this in the chat, but basically yeah, maybe we should first create the abstraction. So but yeah, I need let's do it inside utils, test driver. I don't know how to call it. So if you have or test debugger, CPU debugger, no idea. Let's start with test driver. Export function, export interface, test driver, and then it has like those functions. And I'm waiting for suggestions in the chat or ideas. If CPU debugger, test driver, what would you like to call it? Anyway, so it will have a few methods, a few useful methods. So it will have like set PC, and this is async, and it gets PC number, and it's a void method, and then async write memory address, and buffer. Or maybe we'll have one for write opcode, just opcode number, because most of the tests, they write opcode and not just memory. Async write uint30, or maybe we just should call them write uint16, and write uint32, address number of value number. Yeah, I don't think we need different kinds of write, and it returns void, and then we have this async set register, index number, value number as well, void, async, let's call it single step instead, execute instruction. And finally we need async read registers, and that would probably return kind of ARM register or Cortex. Maybe we should call it Cortex test driver. Registers. Maybe we should, yeah, call it iCortex registers. And then let's define this interface as well. Interface iCortex registers, and it has like R0, all the R's, 2, 3, 4, 5. This is going to make the tests much more readable, in my opinion. 12, and then we have SP, LR, PC, and XI. Do we call it XPSR? And we also have those spatial registers, MSP, PSP. I think we have the Gdp server to help that with that. MSP, PSP, primask, number, what else? Base pri. I don't know if we have base pri. What do we do in Gdp server? And if we don't do it, base pri, yeah. Default mask, we don't have them, so we probably don't test this, so we can ignore this for now. And then there is like the last one, which is control. Cool. So this just returns all the register values. So this is going to be very useful for tests. And we also have like those flags, boolean, and this will be just taken from XPSR, but this is going to be much more convenient in the test code. And v boolean. Right, still no suggestions in the chat for a better name, so I guess it will be Cortex test driver, but you can still come up with good suggestions. Yeah, I don't see why it doesn't like the fact it's async. Probably I should just say it's returning a promise instead of using the async keyword here, which is basically the same. And let's also add read uint16 address number, which returns promise of a number. And same goes for read uint32. And then we can implement test driver Gdp, which will just use the Gdp client. So export class Gdp test driver, and it implements this interface. And now let's just add all these methods. No, not the emoji. All right, and we have a constructor that just gets a Gdp client, so it's just an adapter on top of Gdp client, and then we can implement those methods. So set pc this dot Gdp client, it's private read only, or it can be read only. Yeah, let's make it private. Gdp client dot read write register, and we say we know PC is 15. Const PC equal 15, and oh, let's call it, instead of PC here, PC value. PC value. Let's also make it the same in the interface. PC value. All right, and then so this gets PC value. Cool. And let's make this one async, and then await. Cool. And again async, and then just write memory at address, and then we write we want to new uint16 array with just the value, get a buffer of this and convert it into new uint8 array. Okay, and then do the same here with write uint32 async. Don't need all those promise void, we'll just make those async instead. Cool, so we have this address, and this is new uint32 array. Cool. What else? We have set register, so just set write register, and index, I think it just gets the value. Single step just awaits this .gdp client .single step. So yeah, for the most part, it's just a very thin wrapper around this GDP client. Read registers is going to be a bit more interesting. It will return a new object with all the register values. So we are probably going to dump some, not to dump, to just copy this thing. So, and this is like async, and then const registers is just await this .gdp client read registers, and then these ones are quite easy. Just do here registers and sequence starting from 0. I bet you love that trick of generating a sequence of number. And then for those registers, we're just going to read them directly. Actually, for XPSR, we need it. We are going to need it later for those flags, so we'll just use it here. And then MSP is just this.gdp client.read register. These aren't returned by read register, so we need to read them separately. And let's do the same for those remaining 3. And now we just take their numbers from GDB server. So we have like MSP is 17, PSP is 18, primask 19, and control is 22. And I guess we can also return like base pry and alt mask, even though that's yeah, it doesn't like that, so we don't need to return them right now anyway. Now we only need to do those. So this is like let's see how it works in the RP2040. XPSR is just APSR, so yeah, so we can just copy this and modify it a bit. So, and instead of value, it's just XPSR. All right, XPSR. Okay, so oh, we also need those reading uint and reading uint82 async. Async and promise. Cool. And now yeah, right, PC read uint32. So we are going to read memory, read memory, just reading 2 bytes from the address, and then here we are going to read 4. And then just return new uint32 array, buffer, or maybe let's call it result.buffer. Oh, this is 16. Just return the first element in this array, and here it's like uint32 array. Good. So that's the GDB test driver. Now let's also create a test driver to the emulator. For the emulator, it should be even more straightforward than the GDB. It just takes an RP2040, just an instance of the simulator, and yeah, so it doesn't even have to be async, because we can do everything synchronously. .pc equals pc value, and then just this .rp2040 write uint16, but just, you know, to have the same interface as GDB, let's call it rp2040 test driver. Actually, let's keep it consistent. rp2040 is even no, yeah, okay. Naming is so hard. Address value, same goes for uint32, and then here we have yeah, here we have to be a bit careful. So if index is less than 16, then it's more or less the logic of the GDB server. So this .rp2040 registers at index equals value. Actually, yeah, that's fine. If else switch return, switch index at GDB server. How does it work here? Right register. Yeah, we have this switch that does that for us. Just need to copy it. Index. So just const rp2040 equals this. So we don't need to repeat this every time. And then we need to import those constant. And this one we don't have yet. Yeah, we can probably just do this and assume that nobody is going to pass an index. I mean, this is our test code, so it should be fine. All right, so for the single step, we just this .rp2040 execute instruction, and there is read registers, which is just reading from this .rp2040, just read registers and XPSR from there. And here we have, like, for this we are just Gdp Client no, this I think we have like rp2040 read spatial register MSP and one for the PSP. Another one. This one is going to be for Primark and control, and we can probably do it this way, even though we also have this directly on the RP2040. It doesn't really matter. And two last to go. So this is just rp2040.read uint32 at address. uint16, not 32. This is 32. And good. I think we have the test drivers that set in place now. So let's try that. Let's try to take one of those instructions and migrate it to the test driver. So let's call it CPU is new. Let's start with this test driver. Yeah, we need to import it probably from utils test driver RP2040. Cool. Now let's just call this CPU, and we have to do some changes. Not defined. Just imported it, haven't I? Or what did I import? I believe I imported it. Isn't it exported or something like that? Okay, cool. Now instead of this, it will be set PC, and this is going to be async now. And we are going to wait for this and await CPU write UN16 and write this opcode at, yeah, let's change this. So in our test cases, we written the opcodes to the flash, but I think we can write to the flash on the Pi Pico as well through Gdp, but that would wear out the flash and would be slower. So I mean, it makes just a lot more sense to write the instructions to RAM and await CPU.setRegister R455th. Wait CPU.setRegister R566. Await CPU. Yeah, let's set. Yeah, I mean, it would be nice if we would have setters for those flags as well. So let's create them, like await CPU.single-step. And then we can expect const registers is await CPU.read registers, and then we can just do the assertions registers.r5. Right, cool. So now we only need to implement, why isn't, oh, it needs a new RP2040, an instance of the simulator. And now we just need to implement this setc. So let's do this. So actually, it might be even better. Yeah, if we yeah, I'm thinking it might be even better if we just have an interface that would allow us to set a couple of a list of registers at once, like basically pass in a list of Cortex register instead of like having this. So instead of this, we'll just have, I think this will be a much better API. So partial of this. So a bit more, and not a lot, a bit more work here, and I think we are good. So we have these registers, which is a partial of Cortex registers, and then we can write the test case. First of all, we have now set registers, and registers is partial of iCortex registers, so any subset of this object, and we'll fix the code in a moment, but let me show you how the test will now look much, I think in my opinion, more readable. So it will be something like that. 66 and C true. So instead of having a bunch of set register calls, we just have one, a single one. Yeah, and set PC. Actually, yeah, I think set PC, we can probably keep this method as well, because Not sure. Let's keep it for now. We already have it as a convenience method. Anyway, so now we just need for const key of object.keys of register. So go over each of these registers defined in this object, and we can say switch key and then case, and then deciding by the key which register we want to write to, or yeah. So if it's R0, we can say these dot registers, or RP2040 dot registers at R0 at 0 equals yeah, const value is just registers at key. And I think we need to help TypeScript here a little, because it doesn't know that key is actually, so key is key of type of registers. Oh no, it wasn't very helpful. I want to tell TypeScript maybe key of registers. There is a way to tell keys. TypeScript type keys of object. Yeah, it seems like we can probably say something like key is key of this interface, key of off. Yeah, it doesn't like that. Oh, off. Yeah. Okay, and now key is. I wonder why the type is still string, even though. Yeah, even though we explicitly said a type of object that is type TypeScript. Yeah. For loop. For loop. All right. Yeah, where is the typing here? All right. Yeah, let's just say let's just tell it key is one of those here. And no, oh, I got an idea. Instead of putting the type here, we can say this is just an array of this. Maybe this would work. Number of conversion of the type string to number or key of. Why is it thinking it's just want it to be an array of. Oh, now it works. It was just a parentheses issue. So now it knows that key is finally key is one of those keys, and it's happy about this. Let's actually define it. Anikati, yeah, that's not good to see you here. That's not your fault that you just realized the stream is happening now. It's a spontaneous stream, so we didn't plan it in advance. So it's totally not your fault. Export type I Cortex register name is just one of those register name. And then we can say this is just a list of Cortex register names, and this is happy now. All right, so if keys are 0, then this equals to value break, and then let's just repeat that for all the R's. So again, sequential starting from 1, and same here, sequential starting from 1, and there is no R13, it's just SP, and then there is LR, and then there is PC, and this is 14, 15, and finally we have those spatial ones. There is like XPSR, so rp.xpsr equals this, and then we have which one do we have here? MSP, so write spatial register system MSP value. Why isn't it happy about that? Is not, oh, there's as number. It's a number. It's always a number. We know it's a number. Or no, it can be a boolean actually for some of those. Yeah. So another way to go about, no, let's do this like, yeah, and this is like the place TypeScript sort of start to get in our way. MSP, and then we have PSP, and we have primask as well, primask, and finally we have control. Yeah, and then we have all those like yeah, I'm thinking we may able to create something, use some helper method here instead of now let's continue doing it like that. We can refactor it later after it works. And then we have a few more. So we have, and we can also already see this is red because we still haven't implemented these flags. So we have like N, V, KC, and the last one is like carry. What's the order that we usually use them? NZCV. NZCV, cool, and then RP2040 dot registers equals dot n equals value as boolean. We know it's a boolean. Maybe just do it like that. Registers dot n. Doesn't it like it though? Okay, maybe there is a better way to write it instead of this way. Let's try this. If R0 in registers, then we can say registers.r0. Yeah, TypeScript is still not happy. Okay, let's stop trying to please TypeScript here and just say value boolean as boolean, or just bool value, and use that for those bool value, and then Z break, and then C and V. Yeah, so we created a nice abstraction for the tests, but it did make us work a bit harder in this writing this abstraction. We still have to fix the GDB one, but let's first see why this test failed. V should be false, but received true. Probably some kind of error in reading the registers, I guess. Let's see. So we have this test driver for GDP, and let's print the value. Oh no, the one for the RP2040. And yeah, I guess print the value of xbsr to string 16. Yeah, it doesn't seem like any of the flags is set, so let's just focus on this test and see what is wrong. So it's instructions, and let's focus on this one and then go to the RP2040. And where is this ADCS? Yeah, it does execute the instruction. And let's see if it gets console.log left value and right value 66. Yeah, it does seem to get them right. This.c should be true, is true, and let's see console.log this.v. Wait a moment. Why is it true? How does it decode to true? That's probably something wrong with reading the registers then. Where do we read V? Yeah, are we missing a 0 here? I think if we do, we probably miss it as well in this code, I guess. I mean, copy pasted. So let's quickly check if we just spotted another bug here. I think we did. I think we should have another 0 here when we read and write those registers. Like here. I want to check if we use this value somewhere else as well. Yeah, also here. Interesting way to find a bug. I think it's a bug though. We'll be sure in a moment. Okay, now the test passes, so this seems a bit better. And we can probably commit this. RP2040. I mean, this probably worked because we had a bug in getter and setter, but I think, yeah, as far as I can tell, like those are the high bits. This is a bug. This bit should be empty. Bug in a PSR getter setter used the wrong bit numbers. Yeah, very sad, but we found it. Cool. Right, and now after we finish that bug, so it was already worth doing all this work just to find this bug. Okay, and now let's see what else. So we have this first test that is working with the test driver of the RP2040 of the emulator. And now let's fix the GDB test driver. Let's just copy this thing and then paste it here and or is that now set register is going to be a bit more complex. So this is going to change to, don't have this anymore. We need to import this, and now instead of all of this, we are just going to write register with this number and write the value for all of those. Okay, and then those, yeah. So XPSR is going to be handled differently for now, and these ones we just need to get their indices. So again, Gdp server, and have like MSP 17, PSP. Actually, I guess we can easily create a map instead of this enormous switch register map. It's just like, don't we have it the other way around? Yeah, we do. Yeah, we can probably just swap them. All right, so this is just the index instead of like the value, and then we have XPSR, which is 16, and then those. Now for XPSR we need different handling, so I will show that in the moment. And then we just say instead of this switch statement, we can say if register, if key in register map, then just take the value, const mapped or you can just mapped register, or register index is register map at key, and if register index is not null, if it's there, just yeah, we don't have all of those in the map, so let's just add the spatial ones, just so this is TypeScript is happy. So we have Z, C, V, and yeah, what's the order? NZCV. NZCV. Okay, now TypeScript is happy because we covered all of them. We haven't missed even a single register. So if we have this in the map, then just await this.gdp client, write register, and we write this key. We write the register index and the value. Cool. Now for XPSR, we need to do one of those things. So if we have registers.xpsr, then we need to make sure that yeah, we can probably just write it as well. And then for those, if we have any of them, so we just need to read a value of XPSR, set the right bit, and write it back to enable that flag. We can do something like const spatial registers or flag registers. It's just NZ CV. We can just do for const flag register in let has flag registers, so we can do sort of optimization here. So if we have flag registers, else if we have something that we don't have in this map, then it's probably a flag register. And then if we have those, let's call it have flag registers, not has. If we have flag registers, then const let xpsr is just a way this.db client read registers, there is read register, yeah. xpsr, that's 16. xpsr index is just register map at xpsr, so we are reading this register, or let's just call it xpsr, and then xpsr val xpsr, and then we just need to go over each of those registers and update the bits. So for yeah, const flag bits, and then we have nzcv, and let's copy them again. So apsr and paste them here. Cool. And then we can go for const flag of flag object keys flag bits. If we have this flag in registers, so if the user has passed this flag, then we can just do const flag value is just flag at flag bits at flag, and again we need to make TypeScript happy about this. So this is as key of flag bits array of that, key of type of. Yeah, that's where TypeScript gets a bit cumbersome when you need to type this. Flag is one of those, so why? Oh, syntax error, that's the reason. Let's remove that. So we have flag value, and then we can say xpsr, so that's maybe flag bit, and then or flag bit mask. Const flag value is this dot registers at, oh, not just registers. We are reading the flag, and then we can say we can xpsr. We are clearing this bit. If not flag, if it's false, then we are clearing this bit. Otherwise, or maybe if it's true, we are setting this bit. xpsr value flag bit mask. Otherwise, we are clearing this bit. xpsr. And finally, we can just write this value back after this. Why it isn't like that? Oh yeah, we are going to use it in a moment, so we are going to write to it back. Write register. Register. Okay, cool. So almost cool. Yeah, it should be false, not 0. Okay, cool. So now TypeScript is happy, and we have this enormous, hopefully working set registers method, just so our tests be a bit prettier without a lot of method calls just to update a bunch of registers. Maybe in a retrospect it would have been easier yeah, to break it down to set registers, let's do it. I mean, it's not too complicated, so we can have just no, let's not do it. I mean, in a retrospect, it might have been easier to create set registers and then set flags separately, just to simplify the implementation. So we don't have to. We could have broken this down into one method that does this without taking care of, like, without having to worry about those, and then another method that does this, and this would have been prettier, but it doesn't really matter. The tests are more important. Anyway, finally, let's try to use the GDB test, the GDB test. How did we call it? GDB test driver. GDB test driver. Let's import it. Test driver GDB, right? And we can give it connect to the Raspberry Pi, and the port should be right register is not. Oh, we need to new Gdp client. Okay, so we need to create a client, is new Gdp client with Raspberry, and then tell it to connect, await client.connect to the Raspberry Pi, and the port, the default one, should be fine, and then with the client, and we probably, just with the client. And is this is halfway green? Interesting. What does that mean? Okay, let's just run this test without the other ones. I think it's port error, socket was closed. Yeah, maybe we should also client.disconnect at the end. Just adding a disconnect method. Disconnect, and is just this.socket.close or disconnect. Destroy, I guess. Don't know. And let's also like remove the current rejection handler. Dot reject is just undefined. Just remove it. Okay, so we still get this closed issue. Let's see why. Yeah, I think yeah, there is probably an open connection from an earlier run. Let's run this side by side so we can see the output from OpenOCD as well. Let's change something just so it runs the test again. Ooh, interesting. So what happened here? We had an error, but what error did we have? Byte length of uint array. That's in register. Let's just console log index. And again, probably it kept the connection open. Yeah. 16, 17, 18, 19. So reading register number 19 gives us, let's also console log the response. What is register number 19? Maybe it's, I guess it's, some of the registers are like shorter. So that's probably, let's try it with GDB for a moment and see what's going on. So if we set debug remote to 1 info registers, yeah, I guess, yeah, you can see that for those registers like pry mask, base pry, fault mask, and control, it's just 2 bytes. So we need to fix that. So register may be shorter. So if response.length is just 2, then return decode x byte. Do we have such a thing? I think we should have code xbuff. Okay. And probably decode xbuff response and return the first byte. Okay, so that should probably fix that part of the test. And now let's just restart this guy so it will accept the connection. And let's run the test again. Yeah, we should fix that problem that if we have an error in the test, so yeah, we'll fix it in a moment. So if we have an error, it just keeps the connection open and then it can't use the OpenNCD anymore. Anyway, this is interesting. So yeah, so seems like the test failed because we got the wrong register value. So first of all, let's wrap it with try and finally. So even if we fail, we disconnect, and there is a better way to do it, but for now let's just do this real quick. So now even if the test fails, it should disconnect. Yeah, why do we have this error though? I think if we call client.disconnect, we shouldn't once close. Yeah, when we have disconnect, we should just remove this reject client response. Reject client response. Let's restart it. Run this again. Yeah, drop Gdp connection. Yeah, it's probably like a symptom, but now it seems like it reruns the test. Okay, cool. So yeah, I wonder, let's print registers, console.log registers. Yeah, probably if we are changing it too fast, the test runner is just going too fast. Anyway, so we have those registers and we can see yeah, it doesn't seem to have updated after the single step, the registers. That's interesting. So I wonder what could be the reason for that. The first thing we are going to do is to connect from GDB and just take a look at this memory address to see if it's written the right opcode. Oh, interesting. First of all, we can see PC is like, it seems like it didn't step. It seems like it didn't execute this instruction because PC is set to this address that we didn't seem to have single stepped. We'll check it in a moment, but first of all, let's disassemble what's there. ADCS AR405. Yeah, it seems to have written the instruction to the memory correctly. So something is wrong with single step. What would that be? Why doesn't it single step? If we are doing single step here, it doesn't single step. Maybe, let's see. I think monitor reset init should probably reset the Pi. And now maybe that was a problem. It was like in a problematic state. So let's try that again. Let's go to the test file. Where's that test file? And nice comment, Steve, about the notifications. Okay, let's add a white space. It should run the tests again. And oh, whoa, we got pretty much better. I mean, it almost passes. It seems like the V flag is true for some reason. Yeah, and I think it might have been. Do we have the dump of info registers? yeah, we probably need to, when we start the tests, we probably need just to make sure none of the flags is set. So we probably need to just, set XPSR to some value, probably this without any flag set. XPSR, just this one, which means no flag is set. Okay, let's restart OpenOCD and run this thing again. Where is that? Ooh, now it's happy about something. I think it again, value of PC. I think again we didn't really execute the opcode for some reason. Yeah, for some reason it's sort of stuck in a strange state. I don't know why. Monitor reset init. Probably we should send this monitor command at the beginning of each test just to make sure we are like running in a sort of clean state. Let's see how does that work. Set debug remote 1 monitor reset init. Ooh, RCMD is probably monitor, right? Yeah, it seems so. The only thing it sends yeah, a few messages until we get okay. So yeah, I guess this is like the message. So just RCMD, and I guess this just encodes the reset init. Yeah, it looks like ASCII. So yeah, let's do this GDB. Whenever we construct it, it sends Gdp Client .monitor reset init just to initialize everything, and then create this monitor method. Monitor async monitor cmd string, and then we need to encode it. So const buff is new unit date array cmd.length for I0 to cmd.length I++ buff at I is cmd charcode at I. Just encode this command, and then we need to do this. We need to do await send command, or yeah, const response wait send command. We are going to send qrcmd with this encode hex buff. That's gonna get the buff, and then while response is not okay, just wait, or maybe while response is not okay and response 0 is, they always start with an O, so it should be O something, but not okay. That's O, right? Yeah, it's not a 0. Response is await this.read response. So just read all the messages, and let's just console log them to see that it's fine. It's returning all this garbage until it eventually returns okay. And this is let, and eventually the usual stuff. If response is not okay, then we throw an error. Monitor, where are you? If response is not okay, then valid monitor response. And this, okay, cool. Now I can save this, and this should initialize. And where is the test spec? Let's restart this and see what happens. Drop Gdp connection. Yeah, what happens? Invalid write register response. Oh. But we had this code to handle those O's inside a monitor. Yeah, we got O. Then we should have read another response, and yeah, something didn't go like it should have. We have this O, and then we are waiting for response, and let's print the response here. Should something is oh, I know what the problem is. Yeah, it's an async. So let's have another init method. I mean, constructor can be async, so we are not actually waiting for this to execute, and it keeps executing other stuff. So let's do init promise void, just to let the test driver do whatever initialization, and then we can also have teardown, which is going to be async as well, even though we don't need it right now. And then teardown will also do the disconnection, so we can have something generic. Init and teardown is just this.gdp client.disconnect. Oh yeah, it can be async, it doesn't really matter. And then in the other test driver, RP2040 test driver, we can also have these two methods that basically we don't need to do anything with this RP2040. We just receive a new instance. Yeah, this page intentionally left blank. Just so Eslint want to be unhappy. Well, let's see what's going on now. Well, test file, and here we just call cpu.teardown, and here we have the beginning cpu.init after connecting the client. Yeah, why isn't it happy about this? Oh yeah, we first need to create it. And let's restart OpenCV, run the test again. And what happens? It doesn't seem very happy. Something happens inside init. CPU is not defined. Oh yeah, still haven't defined a CPU. Probably here. That would work better. So now open OCD. Dead. Saving. What happens? Takes too long. Let's try that again, I guess. GDP. No ACK from GDB server. Oh yeah, that's a thing. We won't get an ACK because we have yeah, it doesn't send us another ACK after the initial response. So we can add a new parameter to read response that tell it we don't need an act right now. Need act is true, and then instead of got act we can say go away if need a act, then otherwise need act is false. Okay, and now maybe it will work. I don't know. Invalid response. That init, so monitor, and then monitor here in that command. It should set need act to true, right? Oh, if need act problem. Okay, yeah, seems like OpenOCD got into this weird state again. All right, let's try that again. Maybe this time it will work. DB has this strange set of timeouts, which I don't really understand what's going on here. Like, keep alive was not invoked within the DB alive packet not sent. Okay. I mean, what's going on? We are going. Can't read property 38 of undefined. Okay, let's restart the whole thing for a moment. I mean, it used to work until we added this monitor reset, and now it doesn't work so well. Let's give it another go. So it's running. Yeah, there is this thing with the timeout and the keep alive that keeps it unhappy. But at least we can now see where it went. So it went to monitor, and yeah, it went into this loop. So maybe we'll just log the responses that it gets, so we will have a better idea of what's going on here. But it does read, because now it doesn't fail about the missing act, but maybe we are missing something else. So all OpenOCD and restart tests. Yeah, now it seems like it got into a strange state. Trying again. Running the test, and it will fail, but now we can see the responses. So it got a lot of those, but no okay. Let's see what happens when we try with GDB. Yes. Set remote debug 1, monitor reset init. Yeah, that was, oh, set debug remote 1. That was much faster. Yeah, we should get this O packet followed by this O packet followed by OK. That's not what we get. So maybe we have some problem with the encoding. Let's print the encoded command and compare it with what GDB sends. So GDB sends this. Yeah, Valera, I'm trying to send monitor. That's what I'm trying to do here. But I'm probably doing something wrong because it doesn't work so well. I mean, it does do something, but not what I wanted to do. So yeah, it seems to be sending the same thing as GDB does. It looks very much the same, which makes sense. So there is no problem here. But then I just get these O responses instead of like getting whatever I should get. maybe, just maybe, I should, after reading a response that is not okay, send an X. So just write to the socket a plus sign. I guess this is part of the protocol that we don't see in the dump. So let's try that. So in this case, we just send it a plus to say, hey, we got your O thing, because then it sends these errors. So maybe it's trying to resend them, some kind of mechanism to make sure that GDP got a message. So let's try that. Okay. Run this again. Oh, yeah, that seems to have fixed the bug, or at least you see now it sends an O, and it moves on. So it seems to be like we just missed this kind of ACK to GDP, and now the test is running, or no, it's not succeeding, but it's running again. But still, we have this strange thing where we have v flag set to true. So starting to wonder if this is a bug in the test, or is this the case where we can probably console log CPU read registers.xpsr and restart open. Yeah, and see what's the value here. Yeah, toString 16. Yeah, that's interesting. Even though I just set XPSR to this value, like clear this flag, for some reason it doesn't seem to affect XPSR so well. So it seems like I was unable to clear this flag. Let's see if it works through GDB. Yeah. Info registers. So, oh, here XPSR seems pretty clear. Like, it seems like this bit isn't set, the v flag. So maybe we have a bug in the decoding of XPSR, like we had before. Let's see if that's the problem. Yeah. I still wonder why it reads this value, even though just set it to a different value a line before. But yeah, let's go to the GDP test driver and see. Yeah, we are obviously having the same issue in the decoding where we are missing a 0. I don't know why we haven't fixed that before. So yeah, so that's still doesn't help though. Even though it seems like now, let's rerun the test and see what happens. Yeah, it won't run it because GDB is now connected, so I'm seeing all the results probably. Does it pass now? Yep, it's green. So yeah, so this is the first time since we started working on it that we finally have the same test that can run on the local microcontroller, on the emulator and on the Pi Pico, and we can see that it passes on both. Let's just remove those console logs, and yeah, now the thing is, it gets crazy if it tries to run the test while it's already running. But the cool thing, we can now, instead of like doing all this initialization code here, we can create a new function, async function, create test driver, and then we can have like this before each, or maybe we don't even need this function. We can have this like let test driver is just Cortex test driver, or Yep, is just new. All right, and then before each, we just set sys driver to new Gdp client, and then after each, we can clean it up. So test driver dot async. So before it, we just create a new Gdp client. That's an async. And then we don't need to add this try finally if we do it that way, because we have this like cleanup function that this test runner will run for us. So basically before each, we need to just copy this code. Maybe you can just call it CPU to make our life easier. CPU, and then we can CPU.teardown await, and then we don't need this, and we don't need this, and we don't need this as well, because we can move it here. Cool. And now we have this thing that does the setup and teardown for us, so our test can just execute the logic of the test. One thing we should probably do is import this. So yeah, where is this driver? And it's very unhappy about something. Yeah, now probably all the tests fail. So the thing about this test runner is that it runs all the tests in parallel. So if we have more than one test that is running, then it will try to create multiple copies of Gdp client, and that would obviously fail. Let's just, and OpenOCD isn't running anyway. Let's just run only this test now and see what happens, or what doesn't happen. Why is it? Socket is closed. Interesting. Yeah, let's try to run it just from the command line. npm test. Should only run this test case. And this fails. Socket is closed. How comes? Oh, we didn't client.connect Raspberry Pi. Yeah, now we are seeing the connections, and obviously I think it will fail because the test runner runs it multiple times. So let's run it from the command line. No ACK from GDB server. Where does that happen? Invalid response from GDB server. That's the O. And no ACK from GDB server, but yeah. Well, it worked one time. Now we need to figure out why it doesn't. Let's try it with the test runner again so we can see all the. Now it's, yeah, it failed. Here, this is the response. This snare. Yeah, it shouldn't get an ACK. Where is that monitor? So yeah, so it fails here. It doesn't get an ACK after this QRCMD. What does it get? It did get a plus. Where is that? I think it's a missing await somewhere. Smells like a missing await, but where? We do have an await. Oh yeah, we need to wait for this. Oh, and now it's green. Perfect. So we just missed this await. I think there is a way to let Eslint tell us that we are missing an await. So that could be useful. Anyway, this is green. This is good. I think the last thing we are going to do now is just change this code just a little bit. So instead of creating a Gdp client, it will actually use an environment variable to decide which runner to create. So we can have if process.env.use Gdp client, then it will use the Gdp client, and or maybe we can say use test Gdp server, and then it will use that value as the address of the server to connect to. Else just client CPU is just new Gdp, then that would be RP2040 test driver, and we are going to use it with a new RP2040. So yeah, so in that case we just use the standard test driver, so RP2040. Right, and then yeah, so now if we remove it, it should all be green. Yeah, so now basically our tests will use whatever I mean, we can set an environment variable. So let's do it. So set, I think that's the syntax to set an environment variable in partial Raspberry Pi npm test minus run in band. That tells it to run just one test at a time, and if all goes well, no, it didn't connect to, where did we get this yield? Oh, yeah, it didn't connect to the maybe I didn't set the, let's see if I set, yeah, I didn't set the environment variable correctly. Yeah, how do I set one? Set, oh, just without a set, probably just this way. No, maybe with quotes, and then yeah, okay, now let's try that again. So basically running those tests against, yeah, and we can see it passed, and it did run it against the yeah, it actually ran it. Oh yeah, now it's going, even though we are not using this driver in any of those tests, that we had this before each, so it's going to create a driver for each test regardless. So that's why it takes so long, because it's going to connect to the and restart the Pi Pico for each of those test cases, even though they are not using the driver yet. All right, and now let's do something real quick, because I got tired and it's already pretty late and we are already 3 hours. This is the longest stream so far. So what we are going to do now is just to quickly rewrite this test suite to use the new drivers, and then at least as much as we can in like 10 minutes, and then we can I mean, some of them like WFI or yield, I'm not sure if they will work very well. I'm not sure about that, but other ones will probably be good with this setup. And then we can run this test suite again against the Pi Pico and see if anything fails, and then Valerio can investigate that offline once we have this infrastructure. Cool, so yeah, we can stop this. There is no reason in running all those tests right now, and let's just you know, take a snapshot of what we have so far. And finally, let's just rewrite this whole thing. So it shouldn't take too long. We can just easily replace all of those with, and you can see how many of them we have here. We just cpu.setPC and this value, and then we have a bunch of failing tests now, and that's fine. And oh, we also want to change the address to the Sram address, but just a moment, I need to make sure I make these edits everywhere. Okay, and we can also get rid of these initializations of the RP2040, and now we can change all of those to CPU.write union 16 at the beginning of the memory with this value. And instead of this one, we can do CPU.single step. Oh, and we need to wait for it. And we also need to make sure those ones are async, to wait for them, and also make sure that all the test cases are async. Right, and then this one should also be waited for. And then we have a bunch of other things we need to do. So after each single step, we probably also need to const registers is the await CPU.read registers. And then instead of all of those, we can just accept just registers. And instead of registers, and just remove this and this, and also this. All right, this is, we are starting to get somewhere. Okay, and now we have this like which, first of all, we can remove this double await here. This is just a symptom of like our mess editing. Okay, so now let's see, we are left with those register writes for the most part, and also like this one, we change it to be lowercase pc. Maybe changing it to be uppercase would have been a better choice, but whatever. All right, and then let's see, how do we deal with the remaining ones? So yeah, I have no idea how to do it with a mess edit, so we can just go yeah, I don't think that's one thing we could probably have done easier if we would have a different setter for each register. Yeah, let's just do them cpu.set registers, and then take a few moments, but we will eventually nail it down. And finally, C is true. Okay. Do we have any? Ooh, that's probably R1. Yeah, probably some copy, some mess edit error. Okay. Wonder if we have any syntax errors to here, because yeah, there are too many errors right now. Oh, we have we also have those instructions, like when we write, we can do this in a mess edit. So that's CPU.write uint16 at 20, and then this whatever value, and then that should be changed to wait CPU.write Sram.write uint. Actually, it's writing 1 byte, right? Yeah, we need write uint 8 as well. And that's 24. What is that instruction anyway? Why do we need to write to the RAM here? I think that's a mistake. We shouldn't write to the RAM in this instruction anyway. Yeah, we had a bunch of like other instructions. I don't see any reason why we would write here to the SRAM. That's probably an error in the test. Oh, and this one, we should wait for it. All right. Yeah. Ooh. Let's do a quick sanity. RP2040. I mean, one thing we can probably do to speed things up, and then we can probably refactor it later, just to do something like that. Wait CPU.write registers sp. Just transform each register write to different write registers, set registers. Yeah. Set registers. Okay, cool. And then do something like that for this. Wait CPU.set registers was R1. Right. Many less wait. Okay, same here. Is that the only one? Okay. So we can probably edit here the true, and then we have, and also probably make these ones together. What else do we have? Like should be LR. Instead of this, we can probably await CPU write uint 32, and then instead of writing it here, CPU.write uint 32 and write it in this address, and finally remove this true. This is R3 probably. And I guess this should be 20 and 20. And then CPU.set PC and just 2. And CPU.write uint at write this instruction. Now these are all the spatial cases. And again, CPU.set PC to this value. await CPU.setRegisters Z to true, and then await CPU write uint. This time write this value. Right, so probably refactored. IP, what is IP? IP I think is like R13, R12. Okay. What else? How many of those do we have? Just this. Wait, CPU.setRegisters LR. Okay. Cool. And that was R12, right? IP. Let's keep those two. There's one call to set registers. What else do we have? Yeah. This is just yeah, we can just write uint 32 and just write the whole thing at once instead of two writes like we did before. Uint 32, and same goes here. Uint 32. And yeah, what is going on here? Yeah, we probably need to write. Let's fix it. Registers.sram, interesting. CPU.sram.read uint 8, and we'll add a read uint 8 in a moment. Then we have here await CPU.write uint 8. So writing this values here. Yeah, and then we have LR 42, and we can just put all of those in a single registers call. Okay, and yeah, we don't have this need here. All right. What else? So yeah, await CPU set uint 22. That's relative to the SRAM, so right, that's it. And now we need for this true. And same goes here. No need for this true. And then write uint 8 at whatever this address is. And then if we fill it with 0, we can just write it as uint 32, I guess. And we want to write it 42, right? Yeah, I guess that should do the trick. And here just plus 2455. That's right, uint 8, because we only wrote 1 byte. And here it's plus 12. And here we can probably write uint 32. Just say it's FF55. FF5542. It's Little Indian, so it will be written correctly. And this one 5, and we have here 7766 right here in 16. Right. Whew, there are many of those. So here it's 8, and generally FF55 44 to 11. We have so many test cases. It's not fun when you have to refactor all of them. Yeah, and then this is FF7766. There is some syntax error somewhere here, otherwise this is otherwise it would have run the tests as we write them, and we would have seen some greens, but yeah, maybe we should look for that syntax error, because yeah, line 71, so at least we'll see some greens while we are fixing the tests. Yeah, that's line 71. Let's just look for this C equals true. Yeah, it should be okay. And then is there another syntax error in yield? Where is that? Where do we have this? What's the problem here? Oh, this should be async. This one should also be async. General, are there any other UDF1? Yeah. Yeah, these all should be asyncs. Oh yeah, now we have almost just.fn. This shouldn't have been converted into just async fn, just as.fn. Right, do we have any greens yet, or is there still like syntax errors? What is that? Where is this one? Yeah, probably. This seems to be 2, not 0. Anything else? Yeah, seems to be a bit broken. Or else? Yeah, there is something is strange here. Oh yeah, again. Yeah, probably button bytes 02. What's going on here? That's inside pending SV call, probably here. Yeah, we have like, we are reading the registers twice, so registers 1 and registers 2, just so we are not using the same variable name. And we don't have this pending SV call. What is pending SV call? It is pending SV call. Yeah, I think this is internal. We don't really have this on this register, so yeah, this one should probably not run with the test driver. Yeah, let's for now let's just exclude it. Okay, so now we have a bunch of greens. Those ones, for some reason, yeah, the expectations here aren't good. I think we'll have a few of those failing expectations. Yeah, Yeah, I mean, in some cases, the instructions probably shouldn't be like the tests are testing some internal aspects and not the actual behavior. So what's wrong here? We don't have set uint 8. So it doesn't make sense to use this test driver. Let's write uint 8 and read uint 8, and then Gdp test driver, write uint 16, write uint 8, just gives you this value. And same for read uint 8, just read 1 byte and return that byte. And for the RP2040 test driver, we have that read uint 16, read uint 8, and just call read uint 8. And where is write uint 8? We'll just call write uint 8. Okay, and we have this method as well. Okay, so going back to the instructions, we can see they're pretty much, we converted many of them successfully. There are still a few missing ones. Like this one probably has some issue with something. I guess this should be 8, or this should be, let's check this. What was the original one? Plus 12, and writing, yeah, R6 8, and we were writing at address 8, not 12. So problem here probably. And now it's green. Yeah, so probably a lot of small typos over here. Probably have a bunch of those. So we can fix those all at once, because PC should always be. Yeah, so we still have a few islands of red tests. What's wrong here? Not sure what happens here, why it didn't. Yeah, oh yeah. Wait a moment, we are loading. Let's load from a different address. So we are just overriding the PC with some random crap. So yeah, that makes sense. So again, here probably the same thing. We should just add 10, 10, 10, and then 10. Yeah, now it's happy again. And probably here something similar. No, this is green. Going on here. So this all should have 2 at the beginning. So yeah, so we did a lot of changes at once, like changed the API and also moved all the tests to a different address. So it makes sense that things will break. For instance, no idea why it breaks here. We need to investigate that. What else? Yeah, have those. I think we fixed all of those, or so I thought, but we didn't. So let's fix those as well. And this probably should have a 2 here. No, it's not happy. Why isn't it happy? Oh yeah, we should set PC to this address initially. Not happy yet? Oh, I guess. Yeah, should also write the instruction at that address. Not happy yet. Or not sure what's wrong here. Okay, this passes, this still doesn't. Should have an, oh yeah, that should be, yeah, the address is different. So I think that should probably be +9. Or here, I think here it was fine, but here it was like +9 times 2 + 2, because it should be the next instruction after. If it doesn't take the branch, it probably didn't take the branch, or maybe it did, should have taken the branch, no idea. Let's compare it with the yeah, so we had this, and then we had this yeah, no idea. I think it should have taken, oh yeah, this should be false. That's the problem. Z was false. Now should go to E probably, as it was before. Yeah, okay. So that was just a mistake, typo. Yeah, and now this is with 2, and this is with 2 probably as well, and same goes here. And same goes here probably. And here 2 as well, 2 as well. Ah, so many less reds, so much more fun, and 2 as well. What else do we have here? Oh, this one is quite complicated. What's going on here? Yeah, I think we are writing them to the wrong place, probably. Yeah, now it's happy, cool. And I guess the same problem here. We are reading them from the wrong address. What else? Yeah. Wait, CPU write unit 32. And then FF55 4211. Just write all those at once. And it's happy, great. And then here write uint 8 at address 685. And while at it, let's just make those two a single assignment. Right, more green, great. And then this is write uint 16. And write at this address F055. Why isn't it? Oh, comma. Right. Great or cool or something like that. And this one is, these two ones aren't very easy to do with the test driver, so we will probably revert them to just not use the test driver. And then we have those, here we just need to set false, set carry to false. And it's green as well. And here just await CPU read uint 32. And guess, yeah, we need to do some changes here, like yeah, read from a different address or write to a different address, sorry. And then this one 10 14, yeah, it passes, great. We can put those together as well as this one. Right, and then wait, CPU, radio in 32, and give it the full address. And this is green, great. Same here. Without is true. And this is green as well. CPU.radioInt8. And again here this one as well. And one more green. We don't need the registers here. We can move this. And let's also set those, put those two together. Right, so again, anyway, 32, 2020. Then here we have await CPU write in 32 at 2020. Just put this address, this value, and now it's happy. Let's put these two together. And again, same thing here. Okay, and here as well. Cool, and now the same thing here. Even the same value, or is it a bit different? I think, no, it's the same value. And the same assertion as well, right? No, the assertion is different. Yeah, we are storing a different amount of stuff there. Okay, and the same. How many of those do we have yet? And probably same thing with the assertion. Okay, and then we have those svcall and tst should be. I think we don't need this for tst, right? This is like useless. Or why do we need this value in the RAM? I think it just compares to registers. Yeah, I think it's an error. But then this shouldn't be true. So there is probably a bug here when the registers are equal. Yeah, I think we need to see the original test. There is probably some error here. I'm not sure what's going on here. Why this? Maybe this is not TST, or I don't know. Something it doesn't make a lot of sense here. In this, the test says that the registers are equal. I don't know how this passed. Why this passed in the past? But it doesn't seem like they are equal. I can say they are not equal. Yeah. So R355. Oh, yeah. And then now it should be true. Maybe not. Maybe this is not a TST instruction. Let's test that. So set equals this. Yeah, this is a TST instruction. So what it gives? RP2040 focus TST. It doesn't seem to go into this into here. So where does it go? TST. Doesn't seem to get into. Oh, wait a second. Yeah, we should also single step. That's the problem. All right, it still doesn't pass. Interesting. They are equal. Now it should probably get into TST, yeah. And the result is just, oh, the registers are different. Yes, because I think the result is supposed to be like it's bit wide end, and if they are different than let's say 2, this is different, then we expect the result to be 0. Still not. Yeah, the result is 2. Why is the bit wide end of 55 and 2 is 2? Maybe I'm just too tired and it does make sense. Probably. Yeah, let's make it something that is obviously different. Okay, one more test fixed. Okay, what else? We have no more red, so we only need to revert those tests that are like they are I mean, yeah, we can probably make this specific test so that it remove that SV call pending SV assertion, and so yeah, we can probably fix that. But first of all, CPU.set PC, and then await CPU.write whatever. Yeah, should, and yes, and then everything here should be probably with 2 at the beginning. 2, and then 2, 2, and oh, disable. Let's undisable it. Yeah, and then let's have like we can do something like that. If CPU instance of RP2040 test driver, then CPU.RP2040. So we only do these assertions, this assertion if it's the simulator, because we can't read this value on this that's pending as we call. And same here, this should be false. We can do this assertion on the, this is probably private, so yeah, we'll change it to be not private. Okay, so this is green as well, and now we got only those UDFs, and there is no reason to test them on the actual Pi Pico. It doesn't make a lot of sense. I mean, if GDB breakpoints work, then this is good. So for those 2, and only for those 2, I'm going to revert this to the original test code, or almost. the original test code. Let's just revert those two. Yeah, now everything is green. That's so fun. The only thing I'm going to change the PC just so it will be consistent with the other tests. All right. What happened? Why doesn't it pass now? Yeah. Also, I want to rb2040.write uint16 at this address, write this, write uint32 at this address, write this. Right, so maybe too many zeros. Yep, all right. Cool, so at last we have a bunch of tests that can be run against the real GDB. And on one hand, I'm really tired. On the other hand, I really want to know if how many are failing. So let's just try this real quick and see what happens. Yeah, this has been, it's going to be a 4-hour stream in 10 minutes. So I'm going to cut it in the 4-hour marks anyway, whatever happens, but let's see what happens. How many of them are now going to pass against the actual Pi Pico? I mean, is it running against the Pi Pico? What is going on? Doesn't I don't see any new output. Just seems to be stuck. Oh, there is some output now, right? 74 passed. Yeah, just counting time, but I don't see anything happening. Even though, let's put those side by, yeah, putting those side by side is more fun. But I wonder how comes it just like, it seems like it's running something, but the number is, oh, wait a second. Yeah, the number isn't going, maybe it's just going to run all the tests and then I get a result. Oh, that's too bad. We'll have to wait a lot of time to know what's going on. Maybe it's just running the same test over and over again. All right, so while waiting for it to maybe give us a result or maybe just bail out because I don't know, because there is some bug somewhere. Thanks for the heart, Steve. So now I think it's test refactor tests, mess refactor tests, and I think that could close the issue that we had, this issue from Valerio, issue number 15. Close 15. Create a test driver abstraction allowing us to run the same tests against the physical hardware as well. The emulator as well as the silicon RP2040. Well, I'm not sure if it's going to finish anytime. So Valerio is already showing me, telling me which tests are failing for him if we want to quickly check if we get the same results. Not sure. Should we wait? I mean, I don't know if it's going to, if it's progressing anywhere, or is it like stuck in the loop in a single test, even though it says it's accepting a new connection and then dropping it. So I can assume it's moving forward. Otherwise, why it would run the same test over and over again? Yeah, I mean, we have 172 tests and not all of them are using the driver. only the ones inside this instruction spec file. There are probably many of them. Let's see, how many do we have? We have many. Where is this number? It should appear somewhere here. Yeah, like 100 tests, 98 tests here in this file. So yeah, the interesting thing seems to spend most of the time not talking to this OpenOCD. Like right now, it's lost Gdp connection. Yeah, all those lost Gdp connection is like where we disconnect here in the after each in this teardown. So I think what seems pretty strange is the fact that there is a lot of delay. Like when it starts the test accepting Gdp connection, it goes really fast, but then there is like a big delay between each pair of tests. I wonder, maybe, just maybe, it's something with DNS. We'll give it one more minute while I think we had the IP address of the Pi Pico, yeah. So maybe we can just use the IP address and that would be faster. Maybe that's like the DNS lookup that is taking all this time on every cycle. I don't know. Yeah, we'll give it 30 more seconds to see if we get the results, because it's running for 5 minutes already. So and on one end, it's a shame to just shut it down. On the other hand, we can wait forever. We don't. Oh, all right. So it wasn't forever. It just took very, very long time, and we can see. Yeah, you see all this get other info. This makes me think that this was indeed a DNS problem. Some of them had a timeout. So let's try to use the IP address instead of the host name and run it again. And maybe we'll be more lucky this time. Let's see what's going on. Yeah, wow, that's a difference. So yeah, so DNS was the culprit. And now it's going much faster. Don't worry, this estimated time is just based on the previous run. And now we know that it's like running them 1 per second, so it should take about a minute and a half, and this is pretty nice. Let me paste it to the chat to celebrate that. So now we know which test fail. We can see like there is a bunch of like LDR, and there is a bunch of tests that fail, and I don't know why they fail. And to be honest, yeah, some of them just have, no, this is like the previous run. So yeah, there is like invalid single step response. That seems like a problem with the protocol. Yeah, and I don't know, maybe this test shouldn't check the flag. I don't know, probably some kind of bug. Anyway, I'm just going to go ahead and paste this output in the issue so we can investigate it later. Yeah, this is the entire output. But first of all, let's commit this. I'm pretty happy. The fact that most of the tests are passing. Test GDB test driver output. It makes me really happy. It means that yeah, we are doing pretty good, and I think this one is like false negative, and then we need to investigate all those to understand why they don't work as they should. I guess POP is probably implemented fine, otherwise it's more likely to be problem with interesting with the SV call to see what's going on there. It's probably it's more likely a problem with the test than the implementation itself, but the thing is we can now easily add new tests for more complex sequences of instructions and compare them easily. So let's write this comment. And yeah, DNS is always the culprit. I get it. I understand. I agree with that. Anyway, wow, this has been the longest stream of my life, 4 hours. So it's like 1 a.m. right now, and I think it's a good time to say thank you for everyone who joined. And unless we have another spontaneous live stream, I will see you on Tuesday. That's only in 2 days. Wow. So bye bye.